Good. We are here to talk about how to measure anything in cybersecurity risk with Richard Syverson and Douglas Hubbard. I switched the names around just because I thought for billing purposes. Okay, so the first question, why this book and who is it for? Why don't you start?
10 years ago I wrote a book called How to Measure Anything, Finding the Value of Intangibles in Business. And since I wrote that, one of the more common areas where I might be challenged by someone to propose a measurement method was cybersecurity. And I wrote a little bit about cybersecurity in that first book, but in the quest for looking for other spin-off books, how to measure anything spin-off books in different areas, how to measure anything in project management, et cetera, I decided first to write how to measure anything in cybersecurity risk. And when I asked around, Richard was an enthusiastic volunteer for a co-author, and because I needed a real cybersecurity person, and Richard is real cybersecurity. I'm just the quant guy that's really, trying to introduce certain methods to a new field. And I thought it was an area where it's a really high payoff because I thought we could add a lot to what's currently being done in cybersecurity, and because it's such an important question. I mean, it's a big, risky area.
So I brought Doug in several years ago at one of my previous employers. I had inherited a large area of risk, had a large pen testing team, application security team, vulnerability management, just a large area of risk. And when I looked at the methodologies being used in relationship to the size of the risk, I had that suspicion that something was off. I kind of liken it to like Billy Bean. He knew something was wrong, right? Runs batted in statistic does not make wins, right? I think I had the same kind of feeling there. And so I actually started doing research. I was already doing a lot of data science work. I had a team that did data science, big data, all that jazz. But I still had that overarching strategic problem with how do we start making big decisions about like this application that's, it was a $4 billion investment. This is true. And then several other products that were programs that were 100 million here, 50 million here. How do we start thinking about how we manage risk consistently so we get consistent outcomes and really buy down risk? And I was just really dissatisfied with all of the solutions that I'd seen to date, be they coming from your big four. They do great work, but in this area, I was not convinced. Honestly, what I see from the product space, and I had a career making security products early on, and what I'd seen from the industry in terms of frameworks, they were all really not helping me be better at what I needed to do. So with that, bringing Doug in, I continued to see this as the most important thing for a security executive. How do I quantify risk for the purpose of making better decisions, right? I don't have to go to the board and have them see how we do quantitative stuff. They don't need to know about the sausage factory. I need to be as certain as I can when I go and try to convince them about what I'm doing or what I might need. So hence the book. I wanted to actually learn more from you.
Well, in fact, that project was my first opportunity to really rethink how some of those same methods apply to cybersecurity. So actually, the concepts in that book really started quite a few years before the book when you brought me in.
Good. So, truth be known, I'm a computer network operational attorney. And so when you said anyone with a 7th grade algebraic understanding can get through this, again, I'm apparently challenged mathematically. And we were talking about this earlier. Your system and what you did here, I mean, we hear this in cybersecurity, oh, it's too hard to measure, it can't happen. So the other models that were out there, the other things that were being done, the gut feelings for how I'm going to measure this, how does this differ? And understanding the information here is extensive, and it's a phenomenal read. In a nutshell here, what's different? How did you bring in and attack this problem?
I'll start, and then you
clean up.
Clean up, okay? So all of the approaches in cybersecurity to date that at least I was aware of, and I was pretty well read, were what you'd call qualitative, or more distinctly, they were not quantitative. Counting things alone isn't really quantitative, right? It's when you're actually using statistical techniques that you're actually doing quantitative, where you have some uncertainty, you have some question about what's the likelihood of a breach? What's the likelihood of a breach occurring that would have an impact over some certain dollar amount? When you start speaking in those terms, start asking questions in those terms, you're really starting to do what's truly quantitative work. I think that's probably a key distinction.
Yes. I think when you look at what still is mostly being done in cybersecurity, usually an actuary or quantitative portfolio analyst or someone in operations research, they wouldn't have recognized risk analysis that they're familiar with in cybersecurity. So cybersecurity wasn't really doing risk analysis like that. And in other areas outside of cybersecurity, I was coming across plenty of research related to other works I was working on that indicated that certain kinds of methods actually made decisions worse, while at the same time improving confidence. And I thought, well, those are the same methods that they're using in cybersecurity. So these were measured outside of cybersecurity, but there was research that shows that the use of ordinal scales actually adds error to the intuition of the expert, and then putting those ordinal scales on a heat map kind of adds another dimension of error, and then not adjusting for the known biases of subject matter experts is an error that's avoidable. And so all of the pieces of this clock, all of the gears of this clock were cracked. They're broken. So if the gears of the clock are broken, the clock's not going to work. So I thought, well, we should start with components that work. And there is research that shows that some components measurably outperform others, even if you're limited to using the subjective expertise of your subject matter experts. Some subjective methods measurably outperform other subjective methods. And the ones that measurably outperform other subjective methods are exactly the ones that can produce the kind of quantitative output that an actuary or a quantitative portfolio analyst would understand. So we're actually computing the probability of losing X amount or more in a given period of time due to specific causes.
So if I've got this right, and some of the things you were talking about there, well, first off, it was interesting to have you, I don't want to say simplistically, but being an idiot, measurement. What is measurement? I mean, again, being non-mathematical, I'm looking for, okay, what's my percentage is going to happen? I need a hard number on this. But you talk about what is a measurement in the book.
I treat it as uncertainty reduction. And this is pretty consistent with a whole school of thought in statistics known as Bayesian methods.
Yes, thank you for that.
There's you have a prior state of uncertainty about something that you're thinking about, something that you want, that you're curious about. You make some observations and do some pretty straightforward math most of the time, and you have less uncertainty than you had before. Now, you don't eliminate uncertainty. You don't necessarily put exact numbers on it, but that's not required in most peer-reviewed scientific journals either. Most peer-reviewed scientific journals are about uncertainty reduction, not uncertainty elimination. You just know more than you did before. And that's the real criteria for measuring the effectiveness of methods is, are you measurably better than you were before, right? So even if some of the estimates still feel subjective, and some of them will be, was that method of eliciting the expert input measurably better? Is there research that shows that some methods measurably outperform others? So when we talk about measurement, it's really just a quantitatively expressed reduction in uncertainty based on observation. That's what that means. And that opens up a lot of possibilities for measurement. It's actually a very practical meaning of the word, and it's consistent with science, in fact.
Yeah, Claude Shannon, he's kind of the grandfather or father of information science cryptographer, right? Mm-hmm. Said a lot of pithy things, and one of the things, and I'll probably bastardize this, is information is observation that reduces our uncertainty about an outcome. I'll say that again because it's fun to say. Information is observation that reduces our uncertainty about an outcome. And this last thing, outcome, this is so key, I think, in measurement. This is the thing that I think security folks potentially don't spend enough time thinking about. What's the actual outcome that you're looking for? What's the outcome of the measurement? We can get enamored with measurement stuffs, but the outcome may not require more than 7th grade algebra. It may not even require that much math, right? So I think that's another thing too. When I think about working with my staff, one of the things that we spend a lot of time doing is thinking about what is the thing we're trying to measure. I'm quoting Francis Kettering from the book, right? A problem well-defined is a problem half solved. So I think that's the first thing, really. We can get enamored with the technology. People love complexity, it sells really well. But I think we want to focus really on what is the thing you're trying to get done.
And that was a key point, defining what the measurement's going to be. And that's one of the things where in the law we get the same things like, okay, define the problem. What is the definition of this to get as clear as we can?
Sure.
That was very interesting. So you took this approach, and we talked about ordinal modeling, which, again, coming from the government, we're famous for having our color charts on that. Those different processes are out there, the best practices. You mentioned the placebo effect that we have when we do something and we feel better. These were all things that you discovered as some things are making things worse, and you apply this method to make things better. How do you sell that to get people to understand what you're doing here?
Well, I think the first step is to just raise the doubt that, that feeling that you have, that your judgments and estimates are better, that might just be a placebo. I think people understand what placebo effect is about, and so obviously we're not using it as a direct analogy of the physiological effect that actually can be beneficial from a placebo in medicine. We're talking about any benefit that you perceive is entirely an illusion. There's been multiple studies that show that giving people more time or more structure or more data to analyze a particular problem can easily make them feel more confident. In fact, usually does. There's a direct linear relationship almost between the perceived complexity or formality of the method and how much better you feel about your estimates and decisions, even though your decisions may not have improved at all or gotten worse. So I think this is a dangerous problem. We're making big critical bets based on methods that we know only improve confidence and add certain kinds of errors. Furthermore, I mentioned earlier that there are errors in expert judgment that we can actually adjust for. We can get those expert judgments and then improve on them through error reduction methods just in their judgment.
So is this, to improve, is this the calibration that we're talking about?
Yeah, that's a big part of it. For example, subject matter experts can actually be trained to put probabilities on uncertain quantities or uncertain future events. We've trained at Hubbard Decision Research, we've trained over 1,000 people in the last 20 years, and we've collected all this data. 85% of people who go through a half day of training become statistically indistinguishable from a bookie at assigning odds to things. Bookies are pretty good at it. They're good at putting odds on things. And so everybody can learn, almost everybody, 15% apparently don't get there, but 85% can. And our experience with cybersecurity is that they're above average at doing this. We can get them up to speed in terms of putting subjective probabilities on things. So skip the whole label, high, medium, low, likely, unlikely, or anything. Just use a probability because we know how to do the math with that. We don't know how to do the math with a yellow or a medium or a 2. A 2 is on an ordinal scale or something like that, or a likely versus unlikely. So we're going to use quantitative input, and we're going to train them to do that. We know that one of the problems that experts have is they tend to be statistically overconfident. They put too high a probability on being correct, and they underestimate their own uncertainty. Okay, but that's not the only thing that we have to correct in expert judgment. It also turns out they're highly inconsistent. They give different answers every time you ask them. In fact, we've collected a lot of data on this. About 21% of all the variations in expert judgments about the likelihoods of events are due to just personal inconsistency. They just give different answers every time you ask. So if you can control for statistical overconfidence and inconsistency and apply a couple of other methods, like, for example, decomposition appears to actually improve estimates, even just if you're using expert input. If you allow them to decompose the problem and think about parts of it, and they estimate parts of it, there are conditions under which that decomposition improves their estimates. It's not always true, and we talk about cases where that doesn't apply. But yes, just using expert estimation methods alone, the first thing we say is don't use methods that add error to it, and then adjust for these two errors in expert judgment, overconfidence and inconsistency, and then allow them to think through the problem even further by decomposing their sources of uncertainty, right? Break it up into pieces.
So when you started this, were there any preconceived ideas that you thought, okay, I'm going to find this out, and were there any things that actually surprised you as you did this and went into the book?
I think like many folks in my position. I think they maybe thought, oh, this is something that I could use to convince the board to do something. I can use, my utility belt now has stats on it, and I can whip it out and get people to do things that I want to do. And what I've learned, I learned it really quickly, is it's not for them. By the way, most people who are on a board are mathematically pretty sophisticated. I presented to Jeff Immel at GE. He's got a Dartmouth applied mathematics undergrad and quantitative MBA from Harvard. Smart guy, but I would never use that for him. It's about me. I'm supposed to make decisions and then present those decisions. We're going to do this.
You as a CI,
Me as a CISO.
right.
We're going to do this. This is why. The methods are really, honestly, for me. You're not going to impress those people with anything anyways, no matter what you do. If that's anyone's interest, stop now. So the methods are really about, I'm the decision maker. I'm supposed to be. I'm going to be getting input from, there's machines, but really I'm going to get my inputs from my, the vice presidents, senior directors, what have you, people. By the way, that's how everybody does it. And I want to have that machine really well calibrated so that when I go and make decisions, be it budgetary decisions or what have you, that I feel, you could say feel confident that I've done my homework, that I've done the math necessary so that I can provide hopefully a relatively unambiguous answer to hopefully what's been a well thought out problem.
So your target audience for this book, CISO, who's your target audience thinking?
In my opinion, yes. Anyone who's it could be an analyst, it could be an individual contributor, it could be a manager, senior manager, director, what have you. It could be a CISO. I think most CISOs would probably get through the first half or third of the book, and then they would probably start using the book to press flowers. Because it takes some diligence. It's pretty thick material. I think mostly your analysts, your people who are going to be involved in risk management, managers who maybe run a pen testing team or some sort of operations, they would be the types of folks to read it. Really, anyone who's interested in the application of quantitative practices to operational problems, security or otherwise, should be reading this book.
Well, and in fact, not everybody in cybersecurity or information security has to master these methods. I mean, if you've got one or two people in the organization doing this, there's already in larger organizations some degree of job specialization in information security. So, maybe for a large organization, you have a few people that know this. You don't have to actually teach everybody to do it. You can have your pen testers keep doing pen testing, right? But you should have some, especially if somebody's got a big risk in cybersecurity, a big exposure, then maybe in those environments it justifies having somebody who's really kind of a dedicated resource on this. Personally, I think cybersecurity, writing this book with Richard was my main exposure to cybersecurity. I think it's at least as complicated as the methods that we talk about.
That's the thought process I had, that somebody on the staff has to be doing this. And about all the tools to do this are available in the book and on the website, the different Excel spreadsheets that you have.
Yes.
What are those tools that are there?
Well, we have spreadsheets for some of the parts that seem mathematically a little bit harder. So we just went ahead and just wrote out spreadsheet templates with all the formulas in it. And we explained to people in the book, here's where you go for a Bayesian example. Here's where you go for a simulation example that used this spreadsheet. Here's a different example for how I add up conditional probabilities in Bayesian methods. So there's spreadsheets for all of the steps that seem like they require, further mathematics. Now we start very simple. We actually have one called the one-for-one substitution spreadsheet, which we talk about in detail in the book. And the idea there is that's the simplest version of a quantitative model that directly replaces a heat map. So you're still doing the same things. You're only subjectively estimating a likelihood of an event and then subjectively estimating impact, but instead it's a 90% confidence interval estimate. It's a range estimate, not a verbal scale or something like that. You say it's somewhere between 1 million and 20 million, et cetera. And you do that over and over for really each of the things that would otherwise have been a dot on a risk matrix. There's a row on this table. And we say this is the simplest replacement. So if you get nothing else out of anything else that we're talking about, quit doing the heat map thing and just start using this, because it's the same level of effort, all right? The difference is you're expressing your uncertainty quantitatively, and we can actually add it up in mathematically unambiguous expressions of risk. Things like we explain what a loss exceedance curve is, which represents the probability of losing different amounts of money. We can add up all those risks and produce one of those for a whole portfolio. We know how to add up multiple loss exceedance curves, et cetera. The rest of the spreadsheets just get more detailed. They just break down that first simple spreadsheet into further and further detail so you could use more information when you make your judgments.
You do not have to buy the book to use the spreadsheets. It's freely available. I'm actually going to be presenting at a conference. I've rewritten and done a little extra in R. It's a probabilistic programming language. I'll probably, in the next month or two, be releasing those to the R repository. It's open source.
Yeah.
You know, hey, listen, if an older executive can roll this stuff in software, anybody can do it, right?
Yes.
That's what I say.
Yes.
So the next step, hearing about machine learning, behavioral analytics, artificial intelligence for security, where is that going to fit into the work that you've done here?
So, boy, there's just so many shiny terms out there. I would actually argue that the work that we're doing is naive artificial intelligence. I mean, what is artificial intelligence? We're collecting the beliefs of people about outcomes. We're codifying that and then putting it in software to help augment decision making. It's not quite artificial intelligence. We've said it's more like cyborg. It's a prosthesis for making better decisions.
That's right. I mean, we still have a human element. We're just using methods that we know measurably improve on their human input. But there's other things that are fundamental to how to measure uncertainties that any AI would have to use. I mean, the mathematics of how I update probabilities based on additional observations, that's pretty well established math. If an AI is going to be doing that, they're going to have to be using that approach. Using simulations sometimes are the only way to do the math with lots of uncertain variables. And if I have a given state of uncertainty and then I make some observations about breaches in my industry or a bunch of near misses because I see an extra level of activity and probes in my system, well, I should be able to update all of those uncertainties. And there's math for that. So even the more advanced methods later on are still going to be using that. You know, if more advanced methods start making estimates about, where the planets are going to be, they're still going to use Newtonian physics, right? They're just going to adopt those same methods. So it's fundamental to the whole process. One
observation I've made, having had data science teams and still working around data science teams, they don't do this. They're perfectly competent to do this kind of work. It's not an incompetency thing. It's just that the types of problems that people are solving with data science don't seem to be the same for decision science, like the whole framing of the problem. The fact is, we're dealing with small data, right? We're typically dealing with a lack of data, and that's why we make it up, we simulate it. In other fields, this is called statistics. But,
right.
But we're really dealing with my questions are typically the types of problems I have are what we call irreducible uncertainty, right? And someone would be faced with that and go, well, there's no data, I can't do this. Well, actually, you could probably go along on this. There's a number of fields where that's all they do. They have a small amount of data and they're going to simulate it and go and use that to make decisions. Data scientists don't do that. And I've seen a lot of them really just struggle with these concepts. It's fascinating.
Well, I think to a certain degree, data science has made a big data a kind of a crutch. In other words, they're so used to having so much data that when they're confronted with a challenge of, here's something I need to measure, but it's not already in a big Oracle database on the cloud or something like that, well, then they're stumped at that point. But there's lots of statistics for dealing with small samples or indirect inferences from observations. We tell people, these are themes I've mentioned in the other books, but just assume you have more data than you think, and then try to prove yourself wrong. Maybe it's just a function of how clever and resourceful we are about using different sources of data. What else can I use? And then assume that you need less data than you think and try to prove yourself wrong. Because when you do the actual math, you start finding that those confidence intervals start narrowing a little faster than you thought based on the first few observations. In fact, this is particularly true in cybersecurity. But in some cases, when people have a lot of uncertainty, they presume that you need a lot of data to measure that thing. You know, and does that sound familiar? Right?
Yes.
You know, mathematically speaking, just the opposite is true. The more uncertainty you have, the bigger uncertainty reduction you get from the first few observations. So here's the way to think of it. If you know almost nothing, almost anything will tell you something. That's what the math actually says. And that's counterintuitive to what people are thinking about, but it's exactly in those situations when I have a lot of uncertainty that a little bit of data will greatly reduce it.
So before I ask where we're going on this, if there's going to be another volume, I will say, if I've got this right, I don't know if it was the calibration part, but the interesting part of the book was when you were having folks say, okay, I'm going to give you a set of questions. When was Newton born or something like that? Right. And if you spin this plate and it's going to be 90% you're going to be right, which one are you going to pick? The plate, because you're 90% right there, or when you know the range that Newton was, is that the calibration part?
That was one of the techniques taught in calibrated probability assessments. Okay. So it's called the equivalent bet. It turns out that just pretending to bet money makes you better at assessing odds. In fact, actually betting money is not much of an improvement on pretending to bet money. This has been researched. So you can set up problems where you're trying to estimate probabilities and ranges of uncertain quantities as a type of betting game. And the betting game goes like this. If you're uncertain about what the total monetary impact would be from the loss of availability of system X if it were down for an hour, suppose you're uncertain about that. You think because it's critical to taking orders or something like this that maybe the loss could be anywhere from $1 million to $5 million. That's my initial estimate. Well, with the equivalent bet method, I can think through this problem. What would I rather have? A $10,000 award if the true value, and maybe somebody had perfect clairvoyance and knew exactly what that true value was, right? But I'm uncertain, so I just have that initial range. What would I rather have? Win $10,000 if the true value falls within my range, or would I rather spin a dial that gives me a 90% chance of winning $10,000, 10% chance of winning nothing? Would I prefer A, bet on my range, or B, spin the dial? Well, a lot of people will prefer to spin the dial at first. And that tends to mean, actually it's a little over 80% of people will prefer to spin the dial at first. That means that they must have thought that they were more likely to win by spinning a dial that gives a 90% chance of winning the same amount as betting on their range. So that range wasn't really their 90% confidence interval. They were less than 90% confident in that range. They thought they were more likely to win with the dial. So they should increase their range until they're indifferent between the two. That's why it's called the equivalent bet, right? So when we train people to do this, we ask them questions like, what year was Napoleon Bonaparte born? And they try to put a range on it, and then they practice, well, what would I rather have? Win X amount if the true value, which Doug knows because he's got it on a piece of paper, if it's within my range, or should I just spin a dial? Well, the only correct answer is to be indifferent. If you make your range so ridiculously wide that you always prefer your range over the dial, that's wrong too, right? You need to make them so you're just right. You're just indifferent between the two. That's the equivalent bet. That's just one of a few tactics we train during the calibration training. And we actually observe during the training that people get better and better with each exercise at putting odds on things that they don't know.
It's very interesting. Where does this go next?
This is a good lead-in to actually the last section of the book, where I believe, we're in a post-infrastructure world. I'm clearly there with Twilio. Other than my laptop, they don't give us anything. We have granola, but right. But everything, administrative or otherwise, is in the cloud. By the way, that's the way it should be, and this is not uncommon in the Valley. Mm-hmm. Now, there's Global 2000 where they're actually hiring digital officers, right? Chief digital officers, and the CDO's job apparently is to take that legacy company and make them digital, right? Whatever that is, but that's their job. And so they're trying to really say, let's get a lot of your infrastructure out. We're going to get a lot of this risk. We're going to transfer this risk to the cloud in theory, right? That's going to allow us to be more expressive, more powerful in producing value to the public, right? You make money, I make money by at the rate, the breadth, depth, rate, the whole physics of me producing value to more people, that's how I make money. This is the idea of get this stuff out so we can use APIs, what have you, get more value out there. And this is where the world's going. It's there for us, but everyone's getting there really quickly. So from a security perspective, a lot of infrastructure, it's not there anymore, right? So I don't need those kinds of people. I don't hire those kinds of people anymore. I actually hire people who have a high competency in thinking. I need people who can think logically. In fact, the logic where the variables are random variables, where they're uncertain, that logic's called probability. I need people who have a real good competence, actually good competence all in software, it's a software-defined world, but who, particularly at a management level, are able to think probabilistically, logically about problems, be able to be clear about outcomes. And I actually would bet 5, 10 years from now that assuming I'm continuing to do this, that I'll be surrounded by a lot of very quant MBAs, people coming from MIT, Harvard, Stanford. These would be the people on my staff who have, they can compute, they can do this, but more important, it's how they think about problems, how we go about making bets, not just about cyber, but all forms of risk, right. What I'd call more broadly trust, that's fraud, availability, cyber as well. All those things. Yeah, because we don't own that infrastructure. It's a software-defined world. It's a completely different ecosystem. So managing risk will require a different competency. And I think a lot of the people who work in security right now are going to have to retool because all that infrastructure is going away. That's where I think the future is. And yes, there'll be some other books. We'll figure out what that is.
Yeah, all right. Actually, your earlier comment that people need help defining the problem and what you're used to doing as a lawyer, that's really one of the main obstacles for people believing that something can't be measured. When they say, I can't measure reputation damage, which comes up a lot in cybersecurity, right. They don't quite know what they mean when they say it. I say, show me an example of more reputation damage versus less reputation. What are you imagining? What specific instances, examples are you imagining when you think of higher reputation damage versus lower reputation damage? Again, it's like the Kettering quote, problem well defined is half solved. The same thing is true there. If we go into reputation damage in some detail there. We show a lot of research about it, in fact. But it's just another example of if damage to reputation is scary, why is that? What happens? Does it change your stock prices? Does it change your sales? Do you have to spend a bunch of money to avoid those losses? Extra PR, legal liabilities? The cost of fraud detection services for all your customers and employees, et cetera. So a lot of it is just defining the problem. What do you mean by reputation? What do you mean by security? These sorts of things. Define them in terms of observable outcomes, and then just say, if I'm clever, I've got more data than I think, and if I do the math, I need less than I think.
Which, that was the fast. This is from a legal, you want your lawyer to be the smartest guy in the room who's done the most research and knows everything. This is one of the most well-researched, packed full of data, information I've ever seen. So it's phenomenally done. The tools are available there for everybody to get. I think it is a must-read. As you mentioned, at a minimum, you need 1 or 2 people who are thoroughly up to speed on this in your organization, and I think a lot more than that should be. Thank you so much.
Oh, yeah.
It is a worthy candidate for the Canon Committee. Again, How to Measure Anything in Cybersecurity Risk, phenomenal read, definitely must read.